Let's take a look at a few solving trigonometric equations problems. First up, we have the sine squared of theta is equal to 3/4. And so what we can do is take the square root of both sides. When we take the square root, we end up with the sine of theta is plus or minus the square root of 3/4. That's the square root of 3 over the square root of 4, which is the square root of 3 over 2. And that's what the sine of theta is, plus or minus. If we go to the unit circle, we're looking for the y value to be root 3 over 2 or minus root 3 over 2. It happens at these 4 points. First off, where we're at pi over 3, we get root 3 over 2, and at 2 pi over 3, we also get that same y value. Then down here, at 4 pi over 3, we get the opposite. And then finally, here at 5 pi over 3, we get that same negative root 3 over 2. And so, those are the 4 answers: pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. We wanted the angle to be between 0 and 2 pi, so we stopped there. Okay. Next up, we have sine squared theta equals cosine theta squared theta, and the key is not to take the square root here. In fact, what we maybe should have done over here is to set equal to 0, we have sine squared theta minus cosine squared theta equals to 0. And this is like the difference of squares. It's like a squared minus b squared is a plus b, a minus b. So sine theta plus cosine theta times sine theta minus cosine theta is going to be equal to 0. So this says that sine theta is the opposite of cosine theta, and this says that sine theta is equal to cosine theta. Sine theta is equal to cosine theta. We know one value is when theta is pi over 4. And so, on the unit circle, the sine and cosine are the same at pi over 4. But also down here at 5 pi over 4. They're both negative root 2 over 2. So then where's the sine, the opposite of the cosine? That's in the second and the fourth quadrant. That's going to be at 3 pi over 4 and at 7 pi over 4. One of them is positive while the other one is negative. So that gives us our 4 values between 0 and 2 pi. Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, great. Next up, what would sine 2 theta minus cosine theta be equal to 0? And now, with these, we need some identities. The sine of twice theta is 2 times the sine of theta times the cosine of theta. That's an identity that's true. We can't have both twice theta and theta in the same problem. If we see any twice thetas, we need to break them down to be thetas because we're trying to solve for theta. And so we replace this with twice the sine of theta times the cosine of theta. We leave it exactly as the rest of it is, and now it's set equal to 0. And we can factor out the cosine theta that they both have in common. It'll leave us with twice the sine of theta minus 1. So on the one hand, cosine theta could be 0, and on the other hand, twice the sine of theta minus 1 could be 0. So this says that the sine of theta is a half. And so we need to know, where would the sine theta be half, and where would the I'm sorry about that. Give me a second here. Factor out the cosine theta. We're left with twice the sine theta minus 1. So either cosine theta is 0 or sine theta is a half. On the unit circle, cosine is the x value. It's 0 here and here. That's at pi over 2 and at 3 pi over 2. Sine of theta is a half in 2 places, positive a half here and here. That's going to be at pi over 6 and 5 pi over 6. So we have our 4 answers in order, increasing order: pi over 6, pi over 2, 5 pi over 6, and 3 pi over 2. And then finally, we have the cosine of twice theta plus the cosine of theta. The problem with this guy is that there are 3 identities. The cosine of twice theta is cosine squared theta minus sine squared theta. It's also equal to 2 times the cosine squared theta minus 1, and then it's also equal to 1 minus twice the sine squared theta. So that's the issue. Which one do we choose? And it's probably best to choose the one that has cosine in it. So let's take this one here. Only cosine in it. So we'll have 2 cosine squared theta minus 1 plus the cosine of theta is equal to 0. And think about this as like a quadratic that you have to factor. If you let cosine theta be equal to something like w, we're looking at basically 2w squared plus w minus 1. And we can factor that to be 2w and w, 1 and 1, plus and minus. So either w is a half or w is 1. I'm sorry, negative 1. So either cosine theta is a half or the cosine theta is negative 1. On the unit circle, cosine theta is negative 1 at only one place. That's the x value here. So that's at pi, from 0 to 2 pi. That's on the only place. And then cosine theta is a half, positive a half, at these 2 places. And that's going to be at pi over 3, and then later down here again at 5 pi over 3. So those are our answers in increasing order: pi over 3, pi, and 5 pi over 3. Okay, so if you have double angle and the regular theta, you want to then reduce everything to theta. So you have to find identities that do it. The problem with cosine twice theta is that there's 3 identities, and we chose this one because the fact that there was this cosine here, and so we want to have just one trig function, not the cosine and the sine involved, and that's why we opted out of using these other two. But with sine of twice theta, there's only one identity. With the sine of twice theta, it's just the one identity that's equal to 2 times the sine of theta times the cosine of theta.